Thank you, James. And our final speaker is Professor Valentina-Escott Price from Cardiff University, who is going to talk about polygenic risk score and Biobank. Thank you.
Hello, everyone. And instead of the picture, I put here the formula or equation for the polygenic risk score. It's the simplest one. And if you stay with me and pay attention to what I'm saying, believe me, at the end of my talk, you will know every single symbol, what they mean in this formula. So, polygenic risk scores. It was mentioned already a number of times during this meeting. However, each of us, including myself, we understand different things behind these polygenic risk scores are. So some people think about polygenic risk score when they combine 30, 20, up to 100 SNPs, which are genome-wide significant or close to that. Some people, as the most extreme cases, they talk about putting all SNPs in the genome together, using, for example, Bayesian approaches, accounting for linkage disequilibrium, etc. And that is a polygenic risk score. So from 10, or from 100 SNPs to several million SNPs, and that means different things, and especially for neurodegenerative disorders, you will see, I will convince you that that's different things. Okay, in the UK Biobank. At the moment, just paper appeared in the bioarchives, where they have generated 53 polygenic risk score for 53 conditions and diseases. However, in that particular paper, it is not 100% clear what methods they have used and what genome-wide association studies, independent or dependent on UK Biobank, went to that particular score generations. However, these scores are now available, which people can download and try to use for their research. Also, there were a number of papers using UK Biobank data about polygenic risk scores, improving methodologies, working on a genome-wide association study, including cases and proxy cases and controls from UK Biobank, so it was all great. However, most of the prediction accuracy by polygenic risk scores in the UK Biobank were published for different diseases and disorders, in particular schizophrenia, cancer, obviously because the age at onset is earlier than of those people which in the UK Biobank which don't have dementia, didn't have time to develop dementia yet, or there were publications on association of Alzheimer's or dementia polygenic risk score with respect to phenotypes related to dementia, but not actually predicting Alzheimer's disease or other subtypes of dementia. And why is that? So if you look at the graph here, so that is a histogram of age at onset of dementia in the UK. Okay, that is given in Wales, but it's similar in the UK. When you look at age distribution of individuals from UK Biobank in the year 2022, you can see that majority of them are not reached age at onset for dementia yet. And only smaller than 1%, as it was mentioned already, have already developed Alzheimer's disease or dementia in the UK Biobank. This is why probably the polygenic risk of predicting actual dementia in actual people, actually clinically diagnosed in UK Biobank, is not available yet. However, we should not ignore genetics. And if you look at a summary of factors which contribute to risk factors to Alzheimer's disease, for example, we know that genetics contribute from 60 to 80% of heritability, and that is, to the risk of Alzheimer's disease, and that's from twin studies. And we know that about 35% are modifiable or environmental factors. When we look at genetics only, smaller than 1% of loss is attributed to very early onset, familial onset of Alzheimer's disease. APOE4 is a very interesting gene which contributes 5 to 9% heritability of genetic component to the risk of Alzheimer's disease. Genome-wide significant loss, which now been identified, similar to APOE, altogether 3 to 8%. And the rest is the other SNPs. Other SNPs which did not reach genome-wide significance yet, but they are there, and they are likely to contribute to the disease risk as well. Now, APOE. APOE is a very interesting gene. It's not only the highest risk for Alzheimer's disease, it's also associated with age at onset. So if you are carrying 2 copies of E4 allele, then your age of onset is about 68 years old. And if you are not E4 carrier, then age of onset 16 years in average later. And therefore, obviously, people who are in the UK Biobank, for example, who are about this age now, they will be showing association with APOE 4 alleles more than those people who has not developed the disease yet. And that's why we probably see the predictability by polygenic risk score in different samples varies. That's incidence and prevalence again in Wales, but it's similar in the UK, of dementia split by age groups. You can see that, as we expected, if you go older, the prevalence and incidence increases. However, obviously, people who had APOE4 allele, or 2 of them even, they developed disease earlier. Because they've developed disease, they're young earlier, and frequency of E4 allele actually goes down as population getting older. So that is an amazing paradox. The most risk alleles in the population disappear, but prevalence increases. And that's why I believe, that's the polygenic risk scores for you. And in the older age, more SNPs contributing to the polygenic risk score for Alzheimer's disease or dementias as compared to a younger age. And that is a picture which we've done in UK Biobank for now. Those people who are now diagnosed with Alzheimer's disease, you can see that prediction accuracy by PRS is about 70%. So it was this study recently published also showing similar prediction accuracy. But you can see that mostly they are attributed to APOE. So if you use polygenic risk score and exclude APOE region, the accuracy drops. But we can't check it in the UK Biobank yet, because we don't have enough people at older age who developed the disease, perhaps because of other than APOE SNPs. The other thing which I wanted to mention, and it's not only related to, disease pathology and development, not only related to genetics, and genetics could be different depending on age at onset, but also biomarkers, and that's paper we recently published. And on x-axis here, you can see age. On y-axis, we can see here the values of this particular biomarker. And you can see that biomarker values change with time in cases, which are dark line here, and in controls. And therefore, I support here the Paul Matthews' point that even for biomarkers and for imaging, we need several measurements over time. And even if participants of the UK Biobank are a bit young for now, it is important to start measuring brain images or biomarkers now and repeat it after a few years. So in conclusion, polygenic risk score could be useful to identify individuals at risk. However, the accuracy of current methods are not good enough to take it to clinic. For Alzheimer's disease, APOE is the strongest risk factor, but the frequency of APOE changes in the population as population grows older, and so does the polygenic risk score prediction. And as already been mentioned several times, we need to use a combination of genetics, biomarkers, brain imaging at several time points, and in pathology confirmation when it will be available, to actually provide accurate predictions, not only of dementia in general, but of subtypes of dementia, in this case for Alzheimer's disease. And as I promised, now you know what it is, what the symbols in the formula mean. And my colleagues, of course, acknowledgements to them and to the funders. And also I would like to mention Dementia Platforms UK here, which I didn't put the logo of, because that platform also has UK Biobank data as a part of it, and we are working on unification of standardization, let's say, polygenic risk score in the UK Biobank and in Dementia Platforms UK, so it could be used and interpreted in the same way. Thank you.